Hello guys, welcome once more to Class Online. I'm Tutor Dami. In this edition, we shall be looking at problematic aspects of physics that quite some students find difficult, and we shall be blasting Jamb Physics 2015 question number 11 to 15. We shall be putting dust in the face of Jamb. Now, don't forget that if you learn something from this series, click on like button and we will get to reach you with more content that will better help you destroy Jamb. Now let's get to the question number 11. A dynamo primarily conducts what? Is it potential energy to kinetic energy, or electrical energy to kinetic energy, or mechanical energy into electrical energy, or kinetic energy into potential energy? Do you have any idea which one might be correct? Now actually, this is a dynamo. This is my dynamo beside my bicycle. This is the bicycle of Mr. Dami, and here is my dynamo. Now, but what is the function of the dynamo? It is, now, you know, when you start cycling, the dynamo makes the light of the bicycle, this is the light. It makes the light to come on. Now, this is the light here. Now, so if the function of the dynamo is that the physical implication is that when this person or Mr. Dami starts cycling, when I start to cycle, the light or the bulb around my bicycle will come up when I start cycling, and that what makes it possible is this dynamo. It makes the light to come on, and that's the work. But what is the principle behind what is the conversion of energy that makes that possible? So what is the dynamo doing? It is converting mechanical energy. You know, when I'm cycling, that's mechanical. That is machine. Combination of what? Kinetic energy and potential energy, mechanical energy. It helps to convert mechanical energy into electrical. As the tire is rolling, the dynamo is absorbing the energy I'm using to cycle, and it's creating and it's turning it into electrical energy in the bulb, so that the bulb can come on. So that therefore the simple answer is that dynamo convert mechanical energy in the bicycle, in the tire of the bicycle, into electrical energy that power the bulb, and that is what dynamo is used for. Some people have said that you can even use your bicycle to charge your phone, and that is by the same principle. You just have to convert mechanical energy from the tire as the bicycle is rolling to electrical energy that you use to charge your phone, and that is what the dynamo does primarily, and that's the answer for number 11. Let's check number 12. A particle is injected perpendicularly into an electrical field. It travels along a curved path as depicted in the diagram. The particle is what? Now, what is this particle that goes this way in the electrical field? Do you have any idea which one might be correct? Is it gamma ray, or proton, or neutron, or electron? Now, when you are talking about electrical, there's one that has to do with electrical, and that is in the option, right? Now, let's take a closer look at it. Now, this is it here, electron part. The answer is there for electron. Electron move in the electrical field. Now, this is actually current flowing. Current is flowing this way. Now, we have here charged particles move in parabola. If that bent or curved path, if projected into an electric field in a direction at a right angle to the field. So if it's coming from the right angle direction, this way is the right angle to the field. This is the electrical field. But the electron is coming from right angle to the field. It will move in a parabolic direction. That means it will curve, it will bend, and that's it. Now, in an electric field, the electron moves at a constant velocity at a right angle to the field, but accelerates along the direction of the field. So it begins to go in the same direction with the field, and that's the phenomenon. So the person moving perpendicular to the field, coming at a right angle or perpendicular to the field, to the electric field, is an electron. So electron move. So when the current is moving straight down, the electron moves this way, perpendicular or right angle to the field. So the path of movement of the electron is at right angle to the electric field, and that is the answer to the question. So the answer is just electron, full stop, and that's just it. Let's check number 13. In which of the following diagram is the length of the tube equal to one wavelength? Now, which one is equivalent to one wavelength? Is it this? Now, if you take this one from here, this from here moves this distance traveled by this way. is one wavelength, and that is it. You know, one wavelength is the distance between two crests or two troughs. Now this, let's take this as trough. It began from here, it went up and came back down to the same place. That is a perfect wavelength. But if it begins from here, it went up and didn't come back to the same plane. It went from down to up but didn't come back. It is not one wavelength. And here also we have beginning from here, it went to the middle, it didn't come back to the same place. It is not one wavelength. And here it moved from here, it went up and came down and was still going. That's not one wavelength. So the answer to the question is just option A. It completed one wavelength by going from up and came down, and here it moved up and came down, and that's one. Even from here you can see it here. Here is one wavelength. It moved down, it moved this way, went up, came down, and came back to the same plane, and that's one wavelength. So my answer is therefore option A. It went through the cycle and completed that oscillation, and that is the answer for that question number 13. One wavelength. Now number 14 says a calibrated potentiometer is used to measure the EMF of a cell. Because why? Why do we use potentiometer? Why don't we use voltmeter? You know, EMF can be measured with a potentiometer, and can also be measured with a voltmeter. Now why are we using potentiometer and not voltmeter? Do you have any idea? Is it because the internal resistance of a cell is small compared to that of the potentiometer? Or potentiometer take no current from the cell? Or potentiometer has a linear scale? Or resistance of the potentiometer is less than that of a voltmeter? Now let's check it out. Now potentiometer, it measures the unknown EMF very accurately. That's why it is good. Now while measuring EMF, it does not draw any current from the driving source of known EMF, and that is the best explanation. It does not absorb current when measuring EMF, and that's aligned with the option B. Potentiometer take no current from the cell because it can measure EMF without stealing the current, so it is always clean, and that's why potentiometer is best. It does not absorb the current, it only measures the EMF and leaves the current intact, and that's why many people prefer to use potentiometer to find the EMF of a cell, and that makes option B the correct answer. Unlike voltmeter, it draws current. Voltmeter draws some current. You can see that voltmeter draws some current from the source. So potentiometer is better than voltmeter because one, it is more accurate than voltmeter. Voltmeter gives it in the EMF in approximate value, while potentiometer does not draw current, but voltmeter does. Then while measuring unknown potential difference, the resistance of potentiometer becomes infinite. While measuring unknown potential difference, the resistance of voltmeter is I. Is I, but also finite. So it's not good enough. Now, here also number 5 says it has high sensitivity, but voltmeter has low sensitivity. It is based on zero deflection method. It is based on deflection method. So these are just the difference between them, and why potentiometer is better than voltmeter in measuring EMF of a cell. And that is the answer for number 14. Now number 15 says which of the following is a vector? Is it electric charge, electric potential difference, electric field, or electric capacitance? Do you have any idea which one is a vector? You know, vector means a quantity that has magnitude and direction. Now they are all scalar except one, and that answer is therefore electric field. Electric field have it has arrows that move in a specific direction, right? So electric field is directional, and it is the only vector in that list. So the answer is therefore electric field. It can move in the north, east, south, or west. So electric field is a vector because it has magnitude and it also has direction, and that's the answer to number 15. And that brings us to the end of this video. Don't forget, if you learned something from this video and you want more content that will help you understand physics more and to be able to destroy Jamb, just click on like button and we'll get to send more content that will help you better understand physics. Until we see next time, guys, Take care of yourself, and bye for now.